Hello students. So today we are going to discuss the solutions to the problems given in the exercise of 11th standard Maharashtra State Board textbook, and today's topic that we are going to discuss is electrostatics. So in electrostatics, in the exercise what you will find is the first part is multiple choice questions, and after that there are subjective questions, and after subjective there are some numericals, and today we are going to discuss all those numericals throughout. So let us begin with the first numerical. The first question is written on the board. Just have a look at the question. Two small spheres 18 centimeters apart have equal negative charges. So there are two spheres separated by distance 18 centimeters. They are small spheres and they have negative charges. They repel each other with the force given by the number 6 times 10 to the power minus 8 Newton. And the question is, find the total charge on both spheres. Now this is very basic question, and we will straight away start with the formula. If you read the question, you will understand the question is about force between the charges. Very important line, the force is given. So the force between two charges in electrostatics, it is based on Coulomb's law. So if this is charge Q1 and this is charge Q2, and if they are separated by certain distance r, then the force of attraction or repulsion between them is given by the constant K times the magnitude of charge Q1, we are not interested in the sign, into the magnitude of charge Q2 divided by the square of the distance. This is the formula which is called as Coulomb's law. And in this question, it is clearly mentioned there are two small spheres which we can treat as point charges, and they are separated, that is the distance between them is given 18 centimeters. They have equal negative charges, but if it is a positive or a negative will not make any difference in the formula. So the information is given that they have negative charges, and obviously if they have negative charges, both of them have negative charges, they will repel each other. So when you read the question, you should just look at the important words, important terms in the question. So in this question it is clearly given there are two small spheres 18 centimeters, they are separated by and they have negative charges and they repel each other with the force. So if we look at what is the given data, you will find the force is given. I will just tell what is given. The force is given, the distance is given, whereas charges are not given, and we are expected to find both the charges. So if I substitute the values now, see, force is 6 times 10 to the power minus 8 Newton. Everything we will substitute in SI units. K, the constant of proportionality. Since the medium is not given, we are going to assume that the charges are placed in vacuum. If the charges are placed in vacuum, the constant of proportionality in Coulomb's law is 9 times 10 to the power 9. Charge 1, charge 2 are not given, but they are equal charges. So I can write it as Q into Q, as charge 1 and charge 2 are equal, divided by the square of distance. 18 square. 18 square, but it is centimeters, so while converting into SI, it will become 18 times 10 to the power minus 2. Centi stands for minus 2. The prefix centi stands for 10 to the power minus 2. The whole square. And after simplifying this term, Q into Q is Q squared. If everything is brought to LHS, LHS will become 6 times 10 to the power minus 8 into 18 square is 324 into 10 to the power minus 2 square is 10 to the power minus 4 divided by 9 times 10 to the power 9 will go in denominator. And on simplifying this, I will just continue over here. If you simplify it, Q square will be 9 3s are 27, 5 is left, 27, 5, 32, and 5, 4, 54, 6 are 54. So Q square becomes equal to 6 times 36, and all 10 to the powers, if I combine, this is minus 8, minus 4 is minus 12, and if this 10 raised to 9 goes up, it becomes minus 9, so minus 12 and minus 9 is 10 to the power minus 21. Can I take square root straight away? No. The problem is that power of 10 is odd number. So I'll make it even first. So in order to make it even, what I can do is, I can write this as 60 times 36 times 10 to the power minus 22 is q squared, and then taking square root, you get the value of charge q, that is charge on each of the sphere, because charges are equal. So charge on each sphere will be the root of this 10 to the power minus 22, ka square root will be 10 to the power minus 11. 36 ka square root is 6, and the problem is with the square root of 60. Now in case of, if the number is not perfect square, what we can do is search for the closest perfect square, which is 64, which square root is 8, and the lower side, there is root of 49, which is 7, and our number is between these two numbers, so obviously the answer will be between 7 and 8, but the number 60 is tending more towards 64 and it is away from 49, so I would prefer 7.6 or 7.7 to the right side of 7 and 8. So the answer, approximately I can write it as 7.7 or 7.8, and if I multiply this, 42, 46, so 46.2 into 10 raised to minus 11 Coulomb is the charge on each sphere. To just in order to so that it should look better, it should look good, what I will do is I will just adjust one more 0 and I'll write it 462 times 10 to the power minus 12 Coulomb, which I can write 462 picocoulomb. Now this pico is the prefix which stands for 10 to the power minus 12. This is the charge on a single sphere. But wait, the question is, what is the total charge? So the total charge on this as well as this sphere will be the sum of both the charges, and therefore the final answer will be the total charge will be Q1 plus Q2, and if I add these two charges, both the charges are equal, so that it will become twice of 462. So the answer comes out to be 924 picocoulomb. But still, if you observe the question very carefully, it is clearly mentioned the charges are equal, but both are negative. So if both the charges are negative, it is negative, negative. So the charge on the first will be negative as well as the second will be negative. So the total charge will be minus of 924 picocoulomb. Okay, this was the magnitude. So the total answer should be negative as it is mentioned in the question. Total charge on the sphere, total charge on the both these spheres is minus 924 picocoulomb. This is how we solve the question. So have a look at question number 2. A charge Q exerts force of magnitude minus 0.2 Newton. Now there is a problem with this. Magnitude of minus 0.2 Newton. So there is slight error in the printing. Actually, magnitude cannot be negative. Magnitude of force is always positive. It is a number. But what we can understand from this is, as it is given the force of minus 0.2 Newton, we can understand the force is attractive. So let us consider it in this way. The charge Q exerts force of attraction of 0.2 Newton on another charge minus 2Q. So one is positive charge, other is negative charge. If they are separated by 25 centimeters, determine the value of Q. So even the second question, similar to the first question, is straight away based on Coulomb's law, and for that I need to write a formula. So what is the formula of Coulomb's law? Coulomb's law states that force of attraction or repulsion between two charges is K times constant times Q1 Q2 over R square. This formula is, in this formula we only put the magnitudes of the charges and we get the magnitude of the force. We never put the signs, we never put positive or negative charge signs, we only put the numbers. The constant of proportionality is 9 times 10 to the power 9, and R is the distance. So from the given data, if you simply put the values, the force is given minus 0.2. I won't put minus sign because the force negative means attractive. 0.2 Newton is the value of force. So if I substitute the value of force 0.2 SI units, value of constant is 9 times 10 to the power 9, charge 1 is Q and charge 2 is minus 2Q. But I won't put minus sign, as in this formula you only put the magnitude of charges and not the signs. So minus 2Q will be replaced. We will only put 2Q. We understand the charge 1 is positive, charge 2 is negative, and the force is attractive. Over, distance is 25 centimeters, and if you square it, there will be distance square in denominator, that is 25 times 10 to the power minus 2, the whole square. Because again, centi is the prefix which stands for 10 to the power minus 2. In this problem, we have assumed the medium to be vacuum, so we stick to the value 9 times 10 to the power 9. So now, on simplifying the right hand side and left hand side, bringing all the terms to left hand side, 0.2 times 25 square is 625 into 10 to the power minus 4 divided by the whole numerator, 9 times 10 to the power 9 into 2 is Q square. So we need to simplify this term. If you simplify this term, there is a square over here. So I will try to make all the terms perfect squares. So let us do it. 0.2 tens are 2. That's right. 0.2 tens are 2. So this is 625. I will just mark which of the terms are perfect squares. This is a perfect square. So no need to worry, no need to solve. Directly taking the root, you will get the answer. This is a perfect square. This is a perfect square. The problem was with 10 raised to the power 9. The problem was with 10 to the power 9. So 10 to the power 9 and 10 to the power 1 will give you 10 to the power 10. And on taking the square roots, you will get charge Q is equal to the root of 625 is 25 times the root of 10 raised to minus 4 is 10 raised to minus 2 upon the root of 9 is 3 and the root of 10 raised to power 10 is 10 raised to power 5. And on final simplification, if I take all the powers in numerator, it will become 10 raised to minus 7, 10 raised to power minus 7, and 25 divided by 3 is left as the first term. So after dividing 25 by 3, you get answer as 8.33 into 10 raised to minus 7 Coulomb. This is the charge, or this is the value of Q. This was the question. What is the value of Q? The value of Q is 8.33 times 10 to the power minus 7 Coulomb. Unit is important. Whenever you solve a numerical, the final answer should be written with the SI unit. Okay, so let's have a look at the question number 3. Two charges, 5 microcoulomb and minus 4 microcoulomb, are kept 5 meters apart at point A and B respectively. How much work will have to be done to move charge from point A 5 meters further away from point B along the line AB? So two charges are kept, 5 microcoulomb which is at point A and minus 4 microcoulomb which is at point B, 5 meters from point A. Now question is, how much work is required to push this charge along the line AB away from B? 5 meters further away. So A से C तक, how much work is required to push the charge from A to C? 5 meters further away. Let us say this is point C. So how to calculate the work done to move the charge from A to C? Normally work done we calculate using the formula force into displacement. You know that work is force into displacement. If you use the same logic, you can calculate work over here. But the problem over here is the force acting on this charge that I am going to apply will be exactly equal to the electrostatic force. And electrostatic force, as the distance will increase, is going to change. So this will go into variable force problem. So the work can be calculated as integration of f dx. So using the method or using the formula of work, you can calculate work done to move the charge from A to C. But instead of this approach, we will solve this using slightly easier approach. That is the concept of electrical potential energy. This concept of electrical potential energy is covered in the theory section, and it states that if there are two charges, charge Q1 and charge Q2, separated by distance r,
then the energy stored in them, the energy stored in the system of these two charges, that is electrical potential energy, is given by the formula K times Q1 Q2 over R, not the square. K times Q1 Q2 over R. This is the formula of potential energy, and this formula is sign sensitive. What is meaning of sign sensitive? Sign sensitive means if both the charges are positive or both the charges are negative, you get a positive energy, positive potential energy. If both the charges are unlike charges, one is positive, other is negative, then in that case the potential energy comes out to be negative. So when two charges were at point A and B, we can calculate their potential energy, and when A is pushed all the way to C, now we can find the final potential energy, and the difference in their potential energy will be the work that I have done. So how I can calculate the work done? Work that I have done, work done by Nishant Patwardhan, is the final potential energy of the system minus initial potential energy of the system. How much energy I have increased system, that much work I have to do. So let us calculate the energies in both the cases. First case, what is potential energy initial? Initial potential energy according to the formula is K times Q1 Q2 over distance R. If I substitute the values, the value of K is 9 times 10 to the power 9. Charge 1, charge 2 is 5 and 4. 5 4s are 20, but there is a minus sign, and as it is sign sensitive, I need to take that minus sign. Minus 20, but it is microcoulomb, microcoulomb. And the prefix micro stands for 10 to the power minus 6. So 10 to the power minus 6, 10 to the power minus 6 makes it 10 to the power minus 12. K, Q1, Q2 upon distance R. And the distance R initially, we are calculating the initial potential energy is 5 meters. Both the charges were 5 meters away. So initial potential energy calculation, the distance should be taken 5. 5 4s are and 9 4s are 36. So it comes out to be minus 36. 10 raised to 9, 10 raised to minus 12 is 10 raised to minus 3. Milli, 10 raised to minus 3 is milli, and as it is energy, joule. This is potential energy of the system initially. We are interested in the difference. So for that we need to calculate the final potential energy. And if you observe it very carefully, it will reduce your efforts. Again, putting the formula, substituting the values, all the process will be same except R will be 10, because now it is pushed way to point C. B to C, the distance is 5 plus 5, 10. So the whole formula, everything will be same except 5 will be 10. So denominator will become twice. So the answer will become half. So it will be minus 18 millijoule. This will be the final energy. And if you subtract final minus initial, what do we expect? Minus 18 minus 36 is equal to plus 18 millijoule. This is work done by Nishant Patwardhan. If the question was how much work done, how much is the work done by the electric field, then the answer will be the work done by electric field will be minus 18 millijoule. But since the work done by us, I have performed this much work, electric field has performed exactly the negative work, minus 18. So this is the solution for the third question. Let's go to the fourth question. Okay, so next question is question number 4. 4 charges 6 into 10 raised to minus 8 Coulomb are placed at the corner of a square whose sides are 3 centimeters each. Calculate the resultant force on each charge and show in diagram to scale. Okay, so 4 charges are placed at the corner of a square. So let us draw a square, 3 centimeters side, 3 centimeters each, and all the charges are 6 into 10 raised to minus 8 Coulomb. So all the charges are equal charges. And value of each charge is 6 into 10 raised to minus 8. Okay? All the charges are equal. I won't write the values for all the charges, as all the charges are equal. And the question is, what is the net force on any one charge? Let us choose this one. What is the net force on this? So obviously the net force on this charge, if we name it A, B, C, D, the net force on this charge C will be because of 3 different forces. Because of force of charge B, because of force of charge D, and because of force of charge A. So if you calculate all 3 forces, then you have to add those three forces using the vector rules. So let us calculate the force acting on C because of B, force acting on C because of B, and force acting on C because of A. And as Coulomb's law, formula is similar for all of them. K Q1 Q2 upon R square, K Q1 Q2 upon R square, K Q1 Q2 upon R square. This is the formula. But in case of CB, the charges and the distance will be 3. So let us put the values. What will be the force between BC? It is 9 into 10 raised to 9 times charge 1, charge 2. Charge 1, charge 2, both are 6. 6, 6 are 36 times 10 to the power minus 8. 10 to the power minus 8 is minus 16. K Q1, Q2, product of the charges upon distance square. The square of distance is 3. 3 square is 9. Into, this is centi. The prefix centi is 10 raised to minus 2. The square of it will be 10 raised to minus 4. So after solving this, 9 and 9 will cancel. 10 raised to minus 4 and 10 raised to minus, this is 10 raised to minus 12. And what we get is 36 into 10 raised to, this is 9 and this is minus 12. So what we get is 36 into 10 raised to minus 3. So the first force that we get is 36 millinewton. This is the first force between B and C. In which direction it will be? Obviously, this is positive charge, this is positive charge, there will be a repulsion and the force will be away. This is 36 millinewton. This is the first force CB, which value is 36 millinewton. Now when you will calculate the force between B and C, the whole data will be same. The charges are same, the distance is same. So obviously the force B and C will also give you the same answer, that is 36 millinewton. So this force will be 36 millinewton and positive will be repelling. So force CD will also be 36 millinewton in the same direction. Whereas in case of force AC, while calculating, you will find that everything is same. K is same, Q1 is same, Q2 is same, charges are same. The only difference is the distance. The distance is not 3. The distance is 3 and 3 are hypotenuse, that is 3 root 2. And as the distance is 3 root 2, the denominator square will contain 3 root 2 the whole square, that is not 9, that is 18. So only the denominator will become twice because charges will remain same. K is same. The only difference is instead of 3 in denominator, there will be 3 root 2 the whole square, that is 9 into 2, 18. So denominator will become twice. So what answer do we expect? Not 36, it is 18 millinewton. If you want, I can solve it over here. 9 into 10 raised to 9 is the value of K. Charge 1, charge 2 is 6 into 6, 36 times 10 to the power minus 16 upon distance. This distance is 3 root 2 centimeters. And the square of it is 3 square is 9 and root 2 square is 2. Centi is 10 raised to minus 2. The square is 10 raised to minus 4. Everything is same except this 2. You can compare both these things. Except this 2, everything is same. So 36, answer is 18. So the third force between these two will be in this direction and its value will be, it is FCA. The value of FCA is 18. Iska value 18, iska value 36, iska value 36. Now you have to add 3 vectors. Very simple, the question is now. You have to add 3 vectors. 36 millinewton, 36 millinewton. और exactly उसके बीच में 45 degree पे, exactly at the center, there is another force which is 18 millinewton. So first I will add these two because they are perpendicular vectors. Adding 2 perpendicular vectors which are equal in values is very simple. 36 का resultant, if I use the formula, then it will be 36 root 2. And that force, that is the addition of this 36 and this 36, will exactly be along the 18 millinewton. So in दोनों का addition, the addition of these two vectors, that is CB and CD, will give you the force, that is 36 root 2 along 18. So net force कितना आएगा? Net force will be 36 root 2. This is the addition of this and this vector plus this is 18 already present, and 36 root 2 is 36 times 1.4 plus 18, and after solving this you get the resultant that is 14 6 are 84, 14 3s are 42, and 850, so it is 50.4 plus 18, so the answer comes out to be, the final answer can be written as 68.4 millinewton, obviously. This is the net force and this is the direction. So next question is the fifth one. Electric field in a region is given by E equals to 5K Newton per Coulomb. Now this K cap means the electric field is directed in Z direction. Calculate the electric flux through a square of side 10 cm in the following cases. Three cases are given. Electric field is along Z axis and the square is first placed in XY plane, then it is placed in YZ plane, and third it is making 45 degree with the Z axis. So first let us understand how to calculate the flux first of all. So the formula of calculating flux is in this way. Suppose this is electric field. Suppose this is the electric field that is traveling in the horizontal direction. And if the area that we are concerned about, if this area is area dA, whose normal, the normal to the area, this is generally referred as area vector. The area vector, if it is making angle theta with the field, with the electric field, if area vector, what is area vector? Area vector is a vector which is perpendicular to the surface area, which is perpendicular to the surface area. If that makes angle theta with the electric field, then the flux is given by E ds cos theta. What is the meaning of theta? Theta is the angle between the area vector, not area vector and electric field. So if the area vector is perpendicular to the field is passing right through the area, then area vector is perpendicular to the area, then area vector and electric field will be parallel. If area is parallel, the whole area is parallel to the field ko parallel hai, then the area vector will be perpendicular. And when area vector is perpendicular, cos of 90 is 0. So obviously not even a single line will pass through that area. All the lines are going parallel. And when the area will be perpendicular to the field, means area vector will be parallel to the field. At that time maximum lines will pass. So remember this, theta is the angle between electric field and the area vector. What is area vector? It is a vector which is perpendicular to the surface area. So in this case, the first case is the square is along XY plane. Now see, this is X axis, this is Y axis, and the square is in XY plane. So where will be the Z axis? Z axis is right in this direction. So obviously electric field is along this direction. Electric field is in this direction. What is the value? We are solving the first case. What is the value of E? 5. It is an SI unit. Second is area. What is the area of this square? The area of this square is 10 centimeter cross 10 centimeter will give you 100 centimeter square. So 10 raised to minus 4 meter square. Because centi is 10 raised to minus 2, 10 raised to minus 2, 10 raised to minus 4. So it comes out to be 10 raised to minus 2 meter square. 100 into 10 raised to minus 4. So the area is 10 raised to minus 2. But what about the angle? What about the theta? That is the angle between electric intensity and the area vector. Clearly in this figure, electric intensity is along Z and area vector is also along Z as it is perpendicular to the area. Area ko perpendicular hai. So both of them are parallel. So the angle between them is 0 and cos 0 is 1. So the answer in first case will give you 5 into 10 raised to minus 2. The unit will be Newton meter square. Newton per Coulomb is the unit of E and ds is the unit meter square. Cos theta has no unit. So this is the flux in the first case. This is the flux in the first case. Now what is the flux in the second case? Case number 2. In case number 2, you will observe that the square is along YZ plane. So this is Y axis, this is Z axis, and the plane or the area is in YZ plane. So clearly the plane is in YZ, the plane is lying in the YZ plane, the square, and the electric field is also along z-axis. Clearly it is given electric field is also along z-axis. So what will be the angle between the area vector? Yes, area vector will be perpendicular to the area, ऐसे बाहर, and electric intensity is along z, so the angle will be 90. As angle is 90, the flux that you will get is E ds cos 90, and cos 90 is 0, so no flux will pass in this case. The electric field is along z, and even the area is lying in yz plane, so not even a single line will cross through that surface, everything will be parallel. And the last case where the angle is given with the z-axis, the area square is making angle 45. The normal to the square makes 45 degree with the z-axis. So if you substitute the data, E is 5, ds we have calculated it previously, it is 10 raised to minus 2 SI units, and cos 45, so the answer that you get is 5 into 10 raised to minus 2 into 1 by root 2. And remember, 1 by root 2 is, if you solve this properly, you will get 0.7071, which we will approximately consider 0.7. So if you consider this is 0.7, so 5 sevens are 35, 3.5 into 10 raised to minus 2 SI units, that is Newton meter square per Coulomb. This is the flux in the third case. These are the answers for question number 5. So the next question is the sixth one. 3 equal charges of 10 into 10 raised to minus 8 Coulomb are located at the corners of a right angled triangle, whose sides are 15, 20, 25 centimeters, and find the force at a charge located at 90 degree angle. So let us draw a figure. 3 sides, right angled triangle, the smallest one is 15, then the 20, and the hypotenuse is 25 centimeters. Each side is in centimeters, so we need to convert them into meters while solving. Okay, so 3 charges equal in magnitude are located at 3 different places, and the question is, what is the net force on this charge? Now all the charges are same. On this charge, 2 forces are going to act. If I name this triangle ABC, the force on B will be because of A in downward direction and because of C in left direction, and we have to find the resultant of these 2 forces. So let us find the values first, then we will go for the resultant. What will be force between AB and what will be the force between BC? What is the formula? The formula for force between AB is K times QA QB upon RAB the whole square, and the force between BC is K times QB QC upon RBC the whole square. Substituting the data, the value of K is 9 times 10 to the power 9. Charge A, charge B are equal, both are 10 raised to minus 7. This is 10 raised to 1 and 10 raised to minus 8. So all the charges are equal and are 10 raised to minus 7 Coulomb. So charge A into charge B, if I multiply, it will become 10 raised to minus 14 upon RAB, that is the distance AB. And what is the square of it? It is 400 into 10 raised to minus 4, because it is in centimeters, and when you square centi, it becomes 10 raised to minus 4. So 10 raised to minus 4 and minus 14 will give you minus 10. 10 raised to 9, 10 raised to minus 10 is 10 raised to minus 1. And these 2 zeros which are in denominator, if they go up, will make this 10 raised to minus 1 as 10 raised to minus 3. Because in denominator it is 100, that is 10 raised to 2. If it goes up, it becomes minus 2. Minus 1, minus 2 is minus 3. We are left with only 9 and 4, and 9 by 4 is 2.25 into 10 raised to minus 3, which I can write as force AB is 2.25 millinewton. This is the force between AB. Similarly, we can calculate the force between BC. 9 times 10 to the power 9, 10 raised to minus 14. Once again, charge A, charge B are equal, but the distance is different. This is 15, and the square of 15 is 225 into 10 raised to minus 4, because again it is centimeters. 10 raised to minus 4, 10 raised to minus 14 will become minus 10. 10 raised to 9, 10 raised to minus 10 is 10 raised to minus 1 once again. So we are left with 9 upon 225 into 10 raised to minus 1. I will avoid dividing it by 9 by 225. What I will prefer is I'll multiply. See, whenever you see the number 225, remember 225 4s are 900. 225 4 times is 900. If you see the number 2.25, just multiply it with 4, it becomes 9. So if I multiply numerator denominator by 9, what I get in denominator is 900 into 10 raised to minus 1. This is 9 into 4. So this is 100, and 100 if it goes up, it will make it 10 raised to minus 3. So the answer is 4 millinewton. This is force BC. So we have calculated both the forces now. We have to only calculate the resultant of these two forces. These two forces are acting on this charge. So what will be the net force? The first force, that is BC, is 4 millinewton, and the second force is 2.25 millinewton. What will be the resultant? If you use the vector rules, vector addition rules, what you get is resultant is equal to under root 4 square plus 2.25 the whole square. But instead of squaring 2.25, I would prefer squaring 9 by 4, because 9 by 4 is 2.25. So 9 by 4 the whole square. And that will give you 16 plus 81 by 16. And that is 16 16s are 256. 256 plus 81 upon 16 ka square root will be the answer. And on solving it, I will solve it over here. On solving it, 265 plus 81 upon 16, what you get is 265 plus 81 is 337 upon 16 ka square root. Resultant is, so the answer is 4 in denominator. It is a perfect square. And this 337 is obviously between 324, which is a perfect square of 18, and 361, which is a perfect square of 19. We are between these two numbers. This number is slightly closer to 324. So I will write it as 18.2 or 18.3, 18.2 or 18.3 if I write. And if I divide this now, 4 is a 16, 2 is left, 22, 5 is a 20, again 2 is left, 5 millinewton, because both were in millinewton. So the resultant force is 4.55 millinewton approximately. We have made lots of approximations over here. So this is the answer. Question is, potential difference of 5000 volt is applied between plates 5 centimeters apart. So when two plates are taken and these two plates are separated by a very small distance, 5 centimeters in this case, and the potential difference between these two plates is 5000 volt. Between these two plates a potential difference is maintained. Then if this is a positive plate and if this is a negative plate, the electric field is directed from positive plate towards negative plate. The electric field is uniform, so all the lines are parallel to each other and they are equispaced. So this electric field E can be calculated by the formula electric intensity between the plates will be the potential difference between the plates divided by the distance. And in this question, the potential difference is given 5000 volt upon the distance between the plates is given 5, but it is in centimeters, so I will convert it into meters. 5 into 10 raised to minus 2. On solving this, 5 will cancel. This will become 1000 upon 10 raised to minus 2. If this 10 raised to minus 2 goes up, and this is already 10 raised to 3, we'll make it 1 into 10 raised to 5 SI units. And electric intensity ka unit is Newton per Coulomb. So this is electric intensity between the plates. This is the answer for the first question. And the second question is, if a small oil drop, this charge is given, if I place a very small charge inside, then how much force will act on the charge? If the charge is positive, force will act along the field, that is, it will get attracted by the negative plate, and if the charge is negative, the force will attract it towards the positive plate. And how to calculate force? Then electric intensity is basically force per unit charge. So force will be charge into electric field intensity, which we have already calculated. The charge on this oil drop is 9.6 times 10 to the power minus 19 Coulomb. If you observe it carefully, this charge is of 6 electrons. 6 electronic charge. This is the charge on the oil drop, and the intensity is 10 raised to 5 Newton per Coulomb. So Coulomb and Coulomb will cancel, and if you multiply this, you will get Newton, force in Newton, and that is 9.6 times 10 to the power minus 14 Newton. This is the force on the oil drop. So this is the force, and this is the intensity. So this is the last question of the topic electrostatics. Question number 9. Calculate the electric field intensity due to the charge minus 8 into 10 raised to minus 8 Coulomb at a distance of 5 centimeter from it. Very simple question. It is straight away formula based. If this is charge Q, then what is electric intensity at distance R from it? What is electric intensity at this point? We know the definition of electric intensity. It is defined as force acting per unit charge placed at that point. So as we know, the force acting on the charge at distance R can be given as K Q naught over R square. This is by Coulomb's law. Force can be given divided by the charge that we have brought in. If you cancel it out, you get the formula of electric intensity as KQ by R square. This formula is the magnitude of electric intensity. You don't need to put the sign of the charge. Means you don't need to put a positive or a negative sign of the charge that you are putting over here. Just remember, if the charge is positive, the electric field will be along the direction of the force. It will be away. If the charge is negative, the field will be towards. In this case, the charge is negative, so electric field intensity will be towards the charge. So in this particular case, the electric intensity ka magnitude will be equal to K 9 into 10 raised to 9 times charge, which is 8 into 10 raised to minus 8. See, I am not taking the sign, only the magnitude, upon the square of distance. 5 square is 25 times 10 to the power minus 4, as it is centimeters. This will cancel with this. This will become 10 raised to minus 4, and then this will become 10 raised to 5. So 9 times 8 times 10 raised to 5 by 25 is the answer. Instead of dividing it by 25, I would prefer multiplication with 4. This is 100, and this 100 will make it 10 raised to 3. And now 4 8s are 32, 32 9s are 10 raised to 3. 9 2s are 18, 27 28 into 10 raised to 3. So the answer is 2.88 into 10 raised to 5 Newton per Coulomb is the value of electric intensity. This is electric intensity magnitude. What about direction? Direction will be towards. The direction will be towards charge. Remember, never put the sign of the charge in the formula of intensity.